Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss about two-dimensional flow. So in the fluid dynamics series, we'll discuss two-dimensional flow. It means we'll discuss the flow in the x direction as well as y direction. In the previous videos, we have discussed 1D flow, in which we have discussed all the types of possibilities and all the types of equation of the motion in the impulsive force or non-impulsive force and like etc. etc. So, we will proceed with the 2D flow, and where we will discuss first stream function. Stream function is basically consider a steady incompressible flow of velocity where u I cap v j cap plus w k cap, then divergence will be 0. If I will assume the flow is in xy plane only, then w component, which is the velocity in the direction of z or z direction, it is 0. It means it is a 2D flow. So that we will assume we have only ux plus vy is equals to 0. This is my equation number 1 for 2D, where u is basically the function of x and y, u is basically function of x and y, and v is function of x and y as well. We can write it as the equation of a streamline that we have already discussed, the equation of streamline in two dimension. It is dx by u is equals to dv by v. Okay, so we can write it is v dx is equals to u dv, or I can write it as u dy. Okay, sorry for that. It is dy. It means it is also dy. So u dy minus v dx is equals to 0, or I can write in such a way that v dx minus u dy is equals to 0. Here, if m is equals to minus v and n is equals to u, so we can find that is it exact or not. So we can write in such a way that if minus, or basically the condition of exactness is the partial derivative of dou by dou my is equals to dou n by dou x will be equals to 0, then if it is an exact differential equation, then it is basically the minus dou v by dou y is equals to minus dou u by dou x. Then it means I can write dou u by dou x plus dou v by dou y is equals to 0. It means this will be 0. It means equation 1 u dx, or sorry, u dy minus v dx is equals to 0 is an exact differential equation. So it is exact differential equation. So its solution is basically the u dy minus v dx is equals to some function, derivative of some function xy. Then I can write it as, or this can be written in such a way that u dy minus v dx is equals to some function dou by dou x dx plus dou sine by dou sine by dou y dy. This is some function, or we can write it as, on comparing both sides, where u I will get dou sine by dou x and v is basically the dou sine by dou y, or basically the minus dou sine by dou y. Sine is called the stream function, where sine is the stream function, and the stream function may be introduced such that like basically it is a constant along the streamline for an irrotational flow. It is the constant for along the streamlines, constant along the streamline for an irrotational flow in 2D. If I have Q is such that q is equals to ui cap plus vj cap plus wk cap. Then my w can be written, or like the angular velocity, this is the omega. Angular velocity is basically 1 by 2 curl q vector is basically the 1 by 2 I cap, j cap, k cap, then dou by dou x, dou by dou y, dou by dou z, u, v, w. This w is the component and this w is omega, okay. So it is basically 1 by 2 I cap, okay, 1 by 2 I cap, then dou w by dou y minus dou v by dou z, minus j cap by 2 dou w by dou x, dou u by dou z, okay, plus k cap by 2 dou v by dou x minus dou u by dou y. Because of that, it is 2d. For 2d w is equals to 0, then this whole thing will 0, and only this component will be here. So in xy plane, there is only, because of that, there is with respect, the differentiation with respect to z will not occur. So this term will 0, this term will 0, there is only this term dou v by dou x minus dou u by dou y along the z direction. Okay, it means there is no component in z direction. It means we can write the component of z direction in terms of x and y. If it is a irrotational, if flow is irrotational, then this will be equal. It means dou v by dou x minus dou u by dou y is equals to 0. Can write dou v by dou x is equals to dou u by dou y. So this will be 0. If it is 0, then this will be 0. Then we can conclude this. If I have v is v, we have earlierly that dou by dou x, and it is my dou psi by dou x minus dou by dou y. It is basically the dou psi by dou y is equals to 0, because v is minus dou psi by dou x and u is minus dou psi by dou plus dou psi by dou y. Then it can be written as dou 2 psi by dou x square plus dou 2 psi by dou y square is equals to 0, or it can be written as delta 2 psi is equals to 0. It means the stream function is irrotational, or like irrotational stream function is harmonic. It means irrotational stream function is harmonic function, is a harmonic function. So this is all about the stream function. Now, if it is an harmonic function, then we can calculate this. It means u is dou psi by dou y and v is dou psi by dou x. If the velocities are different on different location of a cross section, we know that by the principle of conservation of mass, the mass has to be conserved. As we basically as we move from the one point to another between two stream lines, and the flux, or basically the discharge through the cross section, and the distance between the streamline must have some relation. So there exists a function representing the relation, which is indeed a stream function. So what is the physical phenomenon of the stream function? It is basically the difference between the flux, or basically the discharge through the cross section, and the distance between the streamline have the relation that is known as the stream function. Okay. Now, if I have some function, or some, I say the flux is my flux, change in flux is basically the dt, and t is the flux. So this is basically the flux along x direction, and dt is equals to u dy. So basically my t is basically a to b u dy. So this is called the flux. What is the flux? The fluid flow from a particular region. Basically, it can be defined in such a way that it is x-axis, it is y-axis, and it is z-axis. Then I have function such a way, basically, yes, the flux is basically this particular region is be the flux, or the fluid flow from this region is called the flux. And if it is my strip, or it is the particular strip, it is basically the dy. It is the dy, and it is along the y direction, or it is a unit. This direction is unit direction. So it is the unit strip. What is this? It is the unit strip along x direction with velocity u, and in y direction, if it is in y direction, then it will be velocity will be v. Okay, so it can be defined in such a way. Now we have this function t is basically a to b u dy. If we use basically the function, we can take a particular example for this. We can find the stream function, and we can find the value of the stream function in such a way that, now we can take an example. So how can we take the example for find the stream function? If u is equals to kx square minus y square and v is equals to minus 2kxy, then what will be the stream function? The stream function can be found as, if what is the u is basically the dou psi by dou y, and v is basically minus dou psi by dou x. If I will calculate the psi from this equation, I can write that it will be the k into the integration with respect to y. It is x square into y minus y cube by 3. It is, if it is a psi, then I have the component v. It is basically the derivative with respect to x. If I will differentiate, or basically on the integrating, here will be the function of y, some function of y, some function of x here, some function of x should be here, or some constant. If I will differentiate this with respect to x, and on comparing with this, I can get also the like this like a particular function, or else if I will integrate, or I will find the stream function by this relation, it is basically the plus kx square differentiating with respect to x, and here will be the constant function y. On comparing these both things, I will get that psi will be, on comparing, this will be my equation number 2, and this will be equation number 1. So by equation 1 and 2, because the stream function will be, that should be unique, or it must be unique. So by this relation or by this relation, the stream function will get the same. Okay, on comparing these both, that psi is basically kx square y minus ky by cube, or some function like for some constant c. Okay, so this is basically the stream function, and this is the process to find the stream function. Or there is another way that you can find, you can differentiate this with respect to x. So you will get the dou psi by dou x, and if you will compare with this, then you can also find the function that is f of x is nothing but some constant. Okay, now what is the relation in the this relation, basically we have u is equals to dou psi by dou y, and v is basically minus dou psi by dou x. These are the Cartesian relation. If I want that, what is my polar relation, what is the polar coordinate system? In the polar coordinate system, the velocity component in radial direction, it means the radial velocity is basically qr, and the angular direction, velocity component in the angular direction is basically the q theta. then it can be written as the radial velocity and the transverse velocity. It can be written known as the transversal velocity. Okay, the radial velocity and transverse velocity, these are two velocities. Then the relation is basically the QR is basically delta psi by r delta theta, and after applying the limit it will be 1 upon r dou psi by dou theta, and q theta is basically the minus of dou psi by dou r. So these are the relation of the radial and transverse velocity with the stream function. Okay. For a particular case, at the stagnation point, basically whereas the theta is 90 degrees, stagnation point where the velocity of the fluid is 0. We saw in the pitot tube, if I have some pitot tube in such a way that if fluids enter from here and it will goes upside from here, then at this point the velocity of the fluid is 0, it means it is at 90 degree. Theta is basically the 90 degree. If in this particular case, what will happen for this particular case, we'll see here. At the stagnation point in the flow region, stream line meet or bifurcate at the angle theta, then the angle is basically the 90 degree. If angle is 90 degree, then it will be bifurcate or meet. Okay, streamline will bifurcate or meet. Like one phenomenon will happen at the 90 degree angle. So we have to prove that angle will be 90 degree. It means that the velocity component at stagnation point is 0. Means my u is equals to 0 and v is equals to 0. Okay, then u is minus dou psi by dou y is 0, plus dou psi by dou y is 0 and minus dou psi by dou x is 0. So these both components are 0, it means my sine function is constant. Okay, it is constant. Then if I have some function such a way that f of xy or with some change 0, if I will expand Taylor series expansion of this function, this is basically the 0, then what will get? Then it will be f of xy plus x into dou psi by dou x plus y dou psi by dou x, dou psi by dou y plus x square upon 2 factorial. It is basically the dou 2 psi by dou x square plus y square by 2. It will be dou 2 psi by dou y square and plus 2 into xy upon 2 factorial dou 2 psi by dou x dou y. Basically this is the Taylor series expansion of the function of two variable. Here if my function is constant, then dou by dou x will be 0, dou by dou y will be 0. It means this will be the f of xy plus x square upon 2 factorial, or basically the x square upon 2 factorial, x square upon 2 factorial dou 2 psi by dou x square plus y square upon 2 factorial dou 2 psi by dou y square and so on. It means this is a type of, what type of? This is basically the ax square plus 2 hxy plus by square, taking up to only y, two terms. It means this is the equation of a curve or a line. Basically stream lines are L1 x plus m1 y is equals to 0 and L2 x plus m2 y is equals to 0. Then this curve is the multiplication of these both lines. It means it can be written as ax square plus 2hxy plus by square is basically the L1x plus m1y into L2x plus m2y. Now if I will find the angle between these both lines, it should be 90 degrees. Okay, now I hope you are getting the point what we are doing here. The angle is basically the L1 L2 plus m1 m2 for two dimensional only, that is L1 square plus L2 square into root of m1 square plus 2 square. Now cos of theta if I will compare these both will be the component or will be the coefficient of x square, then it can be, on comparing, it can be written as a plus b. Okay, this L1 L2 will be the component of x square and m1 m2 will be the coefficient of y square and a plus b, and here will be L1 square plus L2 square power 1 by 2 m1 square plus m2 square power 1 by 2. If I will find the tan theta, this is the angle basically. So what is the tan theta? Tan theta here is, it can be written as L1 m1 minus L2 m2, oh sorry, L1 m2, yeah, tan theta is L1 m2 minus L2 m1 upon L1 L2 plus m1 m2. Okay, now tan theta is, it can be written as, now L1 m2 plus L2 m1 whole square. We make it as complete square, so here will be 4 L1 L2 m1 m2 upon L1 plus L1 L2 plus m1 m2. So the tan theta can be written as, this whole thing can be written as 2 root of h square minus ab, because if we will compare, then this whole thing is basically equal to the 2 into root of this. Okay, now we have L1 L2 m1 m2 is basically the a plus b. If it is 0, a plus b is equals to 0, then tan theta is equals to 1, this will be infinite. Okay, this will be infinite, whereas theta is equals to tan inverse infinite, it means theta is equals to tan inverse tan pi by 2. So it can be written as theta is equals to pi by 2. If theta is 90 degree, then this will happen, where 2 upon h square minus ab should not equals to 0. So this is all about the a particular case at the stagnant point where the velocities are 0 and psi is the constant function. So I hope you are getting this concept and you understand what what is the theorem and what is the 2D flow, in which we have discussed the relation in the Cartesian coordinate as well as polar coordinate system. So this is all about the two-dimensional stream function. So thanks for watching my video. Keep watching MS Maths, and for more videos you can follow my YouTube channel MS Maths. So thank you. Bye bye.